Okay, so this is the video on how to do principal components analysis for data mining. Principal components is a method of reducing the dimensionality of data. So if you have, for example, 20 variables, you might be able to use principal components to reduce the original variables down to like 4 derived variables that are called principal components. So this is all discussed in the lecture video, the theory behind it, but this video is going to implement how to actually do it. So I have here a blank orange screen, and the data that we're going to work with is the cheese data, which is the same data that was discussed in the lecture. The lecture, of course, did not go over how to actually do it in orange. So what you need to do is on the canvas, which again, this is my development environment. It doesn't look like your environment, but it looks similar. So under week 3, you have under week 3, there is a CSV file called tutorial _PCHEs. Again, I always give you the data that I'm demonstrating, and then this will be your assignment, which again is some exercises on principal components. Every week kind of looks similar, not really exactly the same, but there's sort of a similar idea. Once again, I want you to upload the snapshots. Do not upload orange workflows, please. I will not be able to grade them or look at them. So this is what you're going to do. It's a little bit longer. I try to keep them not like super long, because realistically I try to think like a student should reasonably be able to do these in about a 2-hour time frame. So that's about right. If they take too much longer, make sure you're going back to the videos and like checking things. So again, the data is on here. This is my like fake canvas because I work on another computer and I don't download student data on this computer because it's my computer and not for NCC. So I do my development on this computer, which I can do that. Anyways, so under week 3, there will be the tutorial, and this video will be here too, but I can't, like, this isn't complete because I'm actually doing the work, like, as I'm showing this. So, this will be your week 3, and then there are 2 data sets to do principal components on yourself. Principal components is sort of a little more advanced, but not like super advanced. There's a fan going, I'm going to turn it off. So I'm showing you how to do this because it really relates to data mining, and one of the problems you might face is data that's just too big. It's too unwieldy. I mean, analyzing big data sounds like fun, but our human brains can only process so much. So sometimes it's very helpful to be able to take a data set and reduce it to a smaller number of variables called principal components. That is particularly useful in examples such as the cheese data, where the data is somewhat correlated and you have 4 variables that are somewhat redundant. And I showed in the class lecture video all the sort of like combinations of the variables and how redundant they are. So I'm going in orange somehow. I am going in orange, and this is my new orange screen. So once again, I'm going to do a new workflow. I'm going to do the CSV file import widget, which is probably going to be your favorite in this class. And I'm going to click on this. This was done in the last video. So as we go through stuff in orange, it does kind of build on itself. So occasionally you might want to go back and like look at the lab 1 because the lab 2 does use those skills. So I'm going to click on the CSV and I'm going to file recent files. I don't honestly know where this file is, but I have it locally somewhere in the data mining course, which, hey, that would be a reasonable place to put it, under mod 3. And somewhere in here, I have the tutorial _PCHEs. This is the same one that's posted on Canvas for you, but I'm not going to download it on Canvas because I already have it. Okay. Once again, same thing as last time. When you import a CSV file, you get in orange no data types assigned. Okay. So if you try to work with your data like this, you're not going to get anywhere because you actually have to assign data types. So the first thing I'm going to do is set the import options with automatically popped up. Now case, this is just like a row number. It's an identifier. We don't care one bit about this because we just don't for this analysis. So this I can just do ignore. I could call it character. I could just do ignore. It's kind of up to you. So I'm just going to do ignore. And ignore will just do these little weird XE things. Oh, something's wrong with this data. Uh-oh. Now, what's wrong with this data is it doesn't have the column headers. Oh, wait, maybe it does. Wait, hang on. Okay, so we have a problem here. This is actually good to illustrate. Okay, I think this is good. I just want to make sure that I have my variable names in there. I think this is going to be okay. Then these others are all numeric data because principal components, for the most part, you want to do it on numeric data. These are not normalized yet, by the way. These are just like raw like measurements on like whatever kind of weird like taste scale this is. And you can see that like taste is on kind of bigger scale than these, so we will want to like normalize this, which is actually something I have to show you in addition to principal components. So column type, I'm going to do all these numeric, and that's going to work. So now I have all these variables as numeric, and life is good. Okay. Now, the next thing I'm going to do is something that we did not do before. Because I'm not going to work with the full data set, because column 1 is just garbage, and I don't care about that. What I'm going to do next is something new. Not that we've been doing this for so long. So I'm going to actually go and I'm going to choose a widget called select columns. This is very important. Select columns. Okay. And I am going to open this. Not yet, sorry. I'm going to open this and I am going to flow my data into the select columns widget. And the reason I'm doing this is because I only want to work with those numeric variables. I don't want to work with, I have a lot of stickiness in Orange. It actually behaves fairly well, but I have a lot of like not being able to click on things and having to click and click, but that's okay. It's not a huge deal, but I have that. So what I want to do is I'm going to set select columns to only work with the feature variables that I want to work with. Which, interestingly, it's actually already selected correctly, which is perfect, but I have to do this, okay? I have to do this to select only the columns that are going to go through, and then I'm all set, okay? Okay. The next thing I want to do is I want to actually standardize this data. Now, you could look at this with a data table, why not? The problem with this data is that when I do principal components, I want to do them on my standardized data, not on my original data. And this data, let's look at it, is not standardized because you can see the totally different scales. Like this one is like way different. This one is almost kind of standardized, but not quite. And so you want to make sure these are all on a 0 to 1 scale and that they're all comparative. Otherwise, they're not. And what will happen is that this one, because it has bigger measures, will kind of like take over and become like more dominant, and your results will be distorted by that. You don't want that. So we next want to actually standardize them. How do we do that? This is something called pre-process. Okay. And there is a widget called pre-process right here under transform. We're not going to use a ton of this stuff under transform, but pre-process. And so pre-process, what we're going to do is put the pre-process widget on, and then we flow the data from here to select columns, and then we're going to pre-process by connecting the data. So now we've got this kind of like workflow thing where the data is going here, 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 here. Okay. And then click on pre-process. And this kind of looks confusing, which it kind of is. And what you want to do is you want to do normalized features right here. So, because pre-processing actually does a whole bunch of stuff. Admittingly, I don't know what all of it does. This actually looks like it does principal components directly, but I'm not going to do it that way. And then we're going to do standardize to mean of 0, standard deviation of 1, which is the standard normal. Okay. When I say standardize and normalize, this is what I mean. There are slight variations of this, but that's what I mean. And then we're going to close this. Now, what I want to do again is let's look at this. Okay. So now I'm going to do a data table, and I'm going to send the pre-processed data to this. Now I have 2 data tables. It would kind of be good practice to label things, but admittingly, I never do, just because I just never do. So this is original data. Okay. This one's different. Just now there's 2 of them, so I do want to distinguish these. This is going to be the standardized data. There's always like clicky issues. This is also a touchscreen kind of computer, so this is standardized data. Okay, so let's see what it did. Okay, so this is the original data. Okay, let's actually shrink this and put this on here somehow, if I can, which I probably can't. So I'm gonna sort of like put this on here. Okay. All right. is the original data. Then let's get that right at the top. So we're looking at the first rows. I'm not quite sure why. I don't know what's going on here with the row numbers. This is kind of weird. I must have sorted this in some weird way. Okay. Well, that should match up anyways. So I sorted this in a weird way. So I have acetic 13 on top. This is the original data. Now this is the standardized data. Okay, and so acetic 13 is on top. So look at 13. I'm not doing well at my putting my little screens together thing, but I'm trying. Okay. All right. So we have this one, the standardized, and then this one. Okay, good. So look at 13 and 1 here. So the non-standardized, we have 4.47 and 2.9, 1.0, 1.7. The standardized, we have this. Now, when we standardize, we're doing it in terms of z-scores, which measure how far the data values are from the mean. So for the acetic, for row 13, I don't know what the mean is, but it would be helpful to go under feature stats and try that. So let's quickly go under feature stats. So feature stats, which I'm just going to look at and then get rid of. Feature stats, the mean for acetic is 5.48. And the dispersion, I don't know what this dispersion measure is, to tell you the truth. This is not like how, I don't think it's a standard deviation looking at it. But the mean is 5.48 for acetic. Okay. That's all I wanted to look at, 5.48. Okay. So when we go back here, this is 4.47, so that's below the mean. And it specifically is, right, 1.8 standard deviations below the mean. So I don't know what the standard deviation is because it's not the dispersion measure. But so that's what these are doing. This is indicating that the data value is this many below the mean. And whenever you do that, you can always work with these standardized values. And so these are what we're going to work on, not the original data values. We want them standardized, which strips them of their like scale of measure. And you can see these are all between like -2 and +2. These are all standard normal scores now. So that's what the pre-processing standardization step does. I think there's like, quote, quicker ways to do some of this without looking at all the details, but I do want to look at the details, so I'm going to do that. Okay. So that is looking and checking at whether the data has been normalized. And then I'm all set to start my principal components. Yeehaw. Okay. So now what I want to do is, in order to do principal components, you must first determine how many principal components you would like to do. And the best way to do that is by looking at a scree plot. It turns out in orange, and this is going to take a little getting used to, so you're going to have to kind of like watch the videos and kind of like stop and start it and like play around. But don't be too adventurous because I'm making it look super easy because you want to do things in a specific way. So now what I'm going to do is I'm going to find the principal components wizard. Now I'm back on my regular computer, so you don't have all of this stuff because you haven't downloaded it and played with it like I have. But the principal component thing is under unsupervised. And so we're going to take a PCA and put a PCA wizard over here. And now what we're going to do is connect the pre-processed data. We don't need to connect the standardized data. We could, but we don't have to do that. And then we're going to double click on this. And lo and behold, what this actually has for me is a scree plot. This is exactly the one I show in the lecture slides too, by the way. So in the scree plot, what we look for is a bend. Okay, we look for a bend. And we clearly have a bend here. And when you see the bend, that basically tells you that that's the number of principal components you want. So that corresponds with 2. So we really want 2 principal components. There's 4 variables. You could do 1, 2, 3, or 4 principal components. The percentage of the variance captured, what it's doing is it's looking at all the variability data. Percentage of variance captured sort of corresponds with like the amount of the information in the data. So if we just did 1 principal component, it actually captures like about 70% of the data. But if we do 2, it's 85%, which is pretty good. Once we get to 2, you don't get as much return anymore, and that's kind of what the bend is all about. So like, your goal is to simplify the data and reduce the amount of variables. So this sort of indicates that basically this is the point where you've got most of it and you're not going to get that much more, and you're basically just going to like end up with the same number of principal components as you did variables. Remember, a principal component is basically a derived variable that captures multiple variables. So 2 principal components capturing the 4 variables is what I want. Okay. So select the number of principal components to 2, which is already selected. I'm not quite sure why. If we did notice, it also gives the percentage of variance. But so 2 is where the bend in the graph is, so that's good. Now I could have just normalized the variables here, but I like to show you the actual normalization. You can do sort of these condensed steps, but I find it better to actually do them out and look at your normalized data, especially because you guys are basically beginners at this. Okay, so that is the number of principal components it's set. Okay, and this widget here, it's a little hard to see. There's some way to actually find all the Python code behind this. We're not going to get that detail, but there's some, I mean, these are basically function input, function output kind of things. So now what I want to do is I want to actually look at what this thing has produced. So I'm going to get some data tables. Okay, I'm going to get a data table. Okay, because there's 2 things I want to look at. One is the weights, and the other one is the principal components themselves. So this thing is actually run the principal components analysis, and basically like it can output these things. So I'm going to hook it up to a data table. Now, this right here, see, it gives us a bunch of different things. So we have the transform data and the components. Okay. This is what I showed you in lecture. So the transform data is this. Okay. Oops. Again, I have a lot of issues like clicking on stuff in this program. There. Oh, a helpful thing to do actually is to clear and then redo it. I don't know. I mean, I have 3 computers and they all sort of behave differently. So what I want to do is send the transform data. Okay, the original data, no. And then I'm actually going to do the components too. We're doing the 2 steps. So this right here is going to be the data with the principal components, basically. And when I click on this, I should actually be able to show the data as well. I wonder if I could do both. Yeah, no, I can't. Interesting. This does. Hang on. I want to show. Those are the weights. Okay, I don't want that. Well, I do, but I want that next. Okay. So you click on the connector, and in some cases, the connector, like here. I mean, the only thing that's here is data to data. There's no other options to send out except the data. But here, when we run the principal components, it's producing a couple of things. So we have the transform data, the original data. I wonder if this does it. What that does. Yes, this is what I want. So now this is the original data, but it also has the principal components, which are also known as the transform data. So this is actually what I showed you in the lecture slides as well. These are the 4 variables that are normalized, and then these are the derived variables and principal components. So each data observation, which there's 30, has a calculated principal component. And in the lecture videos, I actually went through the algebra of how you would take these and get this. So we have 2 derived variables, each of which is going to have an algebra formula that you take these 4 input variables and you weigh them, kind of like a linear regression kind of thing, and you weigh them and you make this value. Okay, so this is the like data. This is sort of like the old data is the 4 original variables, and the new data is the transform principal components that you can do things like cluster analysis on the principal components. Okay. That is actually like cool. Okay. Okay. One other thing you could do is you can look at a scatter plot of the principal components. And the reason you might want to do this, so I'm going to do a scatter plot of the principal components, PC1, PC2, is sometimes you can actually see like clusters and stuff in here. This one isn't really like super clustered, but this is not the original variables. There's now 2 variables, PCA and PC1. These, if you look at this is actually important. These are not correlated, and that's the whole idea. So you're taking, remember all 4 of the original variables were correlated, but when you make these principal components, you're creating these new uncorrelated derived variables, right? And so uncorrelated basically means they're capturing totally different information. They're not redundant. And that's why like two principal components is good. But so the other thing I want to look at is the weights, because to do the algebra to get from the data values to the principal component values, you need to create these little equations where PC1 is equal to something times this, something times this, something times this, something times this. Those somethings are the weights, and you can get those here. So you can do another data table. Okay. And you can do, so I'm going to label these to be good. If there's like multiple things that are similar, so this is like data with PCs. So those are like the transform variables is what they're called. And then also I'm going to do this. And this is going to be the weights. Okay. Because this is what would give you, now I mean the software is doing it for you, but if you had to do this by hand, these are essentially your, this is what you can make your equations of. So these are the weights. Okay. And now I want to change this. They call it the components. I call it the weights because I learned at the University of New Hampshire, and that's what they call them there. So the components is this, okay? And that's these. And what these are, okay, is if you multiplied, okay, let's try to do this again. I know I'm like going crazy here with these things. Okay. So, hopefully I can get these on together. Whoa, I like have no idea. Okay. I'm not super skilled in my showing multiple windows at the same time, but I'm trying. So, okay, this should work. Oh, yay, I'm getting there. There's hope for me. Okay, so for row 1 here, if we want to get this PC1 value, which is negative 2.86, what we would do, it's also helpful to flip this, but I'm not going to because I'm just being sort of lazy. What I would do is I would do 0.4 times the negative 1.7 plus 0.5 times the negative 1.3 plus 0.5 times the negative 1.9 plus 0.5 times the negative 0.6. And that would give me the new principal component 1 because I'm going by these are the weights slash coefficients. This variance is just the same thing as this. This is just repeating the percentage of variance that principal component captured. So essentially you just make an equation that PC1 is equal to 0.46 times the acetic plus 0.51 times the sulfuric plus 0.50 times the lactic plus 0.51 times the taste. And you can plug in all of these numbers, and you could probably just do this in Excel and get the principal component 1, which would be this one, and then there's a second principal component, and then you've created the derived variables algebraically. So that's what the weights do. And if you didn't have software that like did these like auto calculations for you, you'd have to like do all that, like, in the old days kind of thing. Okay, so those are the weights. You can also flip this. I'm going to be sort of lazy and not show that, but you can flip it pretty easily. Well, actually, maybe I will show you. This is just a small table, and this is kind of a data wrangling thing. But if you want to make it look a little nicer, you can transpose the table. And so I'm going to do a transpose widget and then just another data table widget. And I'm going to show you like how to like flip this. So this goes in here, and then this goes in here. And then when I click on this one, this is like a little nicer, except it only flipped the first principal component. I don't know what happened in a second. I probably had it selected. Yeah, I did. So if you have something selected, by the way, like I just had this selected, and so that's why I only got PC1, but if I unselect it somehow, or select both, or just something like that, there we go. So it's unselected. And so now I'm going to get both in here, which this just makes them like a little like easier to read. So that is, and the final thing is to try to interpret these. Now that is, you just interpret these. So you interpret them by the weights. Like you just look at what it's weighing. So this first principal component is sort of weighing like all 4 of these evenly. So you could kind of like be like, well, this is like a derived variable that captures like sort of like the overall average of these different metrics of cheese taste. That's what the data is by this cheese taste. The second principal component seems to very heavily weigh the acetic acid with the 0.85, and then maybe the acetic acid against taste. The other two seem to be really sort of small, like negative 0.09. That's not a very big weight. Negative 0.2 is a little bit big, but not as much. So domain experts are really needed though to like make an interpretation of those. But that is how to run a principal components analysis, taking a bigger data set and then condensing it down to the principal components. And I have a feeling you're going to have to watch this video a couple times while you do your assignment. But your assignment is on the Canvas, and you are to look at, there's 2 data sets, there's 5 questions each. I didn't get like super sophisticated, but I asked you to do, run some principal components for this peas data, which has characteristics of peas, the vegetables literally. So just do the normalization that you should know how to do. Do the scree plot, show the data table with the principal components, and then show the weights. So that's basically what I'm asking you to do. I didn't really ask for too much like highly technical, just to be able to run it and get a feel for how to run the principal components in Orange. Okay, so that is good stuff.